Hi there, we're at Hardware and Glass Testing Facility in Perth, and today we're going to demonstrate deflection on PVB versus SGP. So we're going to test PVB and SGP at a low temperature, and we're going to test them both at a higher temperature. So first of all, we're going to start off this morning, 18.8 degrees. So we've got a piece of PVB, 14.28 in position here. So we're going to load this up, record the deflection, and we're going to come back later this afternoon when it's warmer, and we're going to redo both tests again and then record the deflection and show the difference that the temperature has effect on the balustrade system. So testing in different temperatures. Okay, so we'll load this up here. Okay. So we're going to load this up to 0.75. Get a hold on it there. Okay. So we're at 52.9 mil deflection. Hi there, we've just set up test number 2. So this is using SGP glass, same size panel, 14.28, at the same temperature, 18.9 degrees as the PVB. So let's load this up to 0.75 and record the deflection. Okay, so we're at 25 mil deflection. Alright, so this is test 3 we've got set up. As you can see, it's warmed up a bit now. We're at 25.7 degrees. We're going to retest the SGP panel, record the deflection as well, and we'll compare that to the data that we took when it was colder. So we'll load this up now to 0.75 and record the deflection. Okay, so we're at 25.6, which was the same as what we had before. Alright, so we got test number 4 set up here, which is the PVB at the higher temperature, which is 25.6 degrees. So now we're going to load this panel up to 0.75 kilonewtons and record the deflection. So as you can see from the heat, makes a big difference when it comes to PVB glass. So we're at about 80 mil deflection there. So as you can see, the difference between the colder temperatures and the hotter temperatures. The SGP glass, we didn't really have any movement at all. I think it was about 0.2 of a mil. But with the PVB, we've almost had 30 mil difference. We're only talking about 7 degrees hotter. So when testing PVB, it needs to be tested in a climate control room. Thanks. Alright, we've just set up another test here using 12 mil toughened glass, a metre by metre panel. We've got some spigots here that we've sourced from a company in Australia. These spigots come with certification, so it's got a signed document saying that it's certified, it passes Australian standards to be used for balustrade. So we're just going to demonstrate here to see if these actually do pass. So what we're going to do is we're going to apply 0.75 kilonewtons as a uniform distributed line load across the top of the piece of glass and see what the deflection does. From what we understand in the code, we reckon the deflection should be under 30 mil as a balustrade system. So these are only minimum requirements. 0.75 would only apply per metre. So if we're going bigger, we need to multiply that. Also, if we're going to use high buildings and multiple levels, then it's going to be multiplied again. So this is just minimum loading requirement. So we'll load this up now to 0.75. Now, from what we understand is that the deflection should stay under 30 mil. Pass. Okay, so let's just bring this up here to 0.75, which we're at that there. So this is minimum load requirement for uniform distributed line load. 0.75 kilonewtons, and our deflection's at 32.16 mil. Alright, as you've seen from the last test, we were 2 mil over the recommended deflection for 0.75 loading. This is only one factor in the whole process of testing. So, and also, this is only one sample. We've got multiple samples, multiple test reports that I've overlooked, and everybody's testing differently. This guy's testing this way, he's testing that way, he's doing his load this way, he's doing his load that way. So it's just finding a set report that everybody tests to and keep the standard all the same. Thanks.